Hello everyone, this episode is about AWS KMS or Key Management Service. Now KMS is used to encrypt data on AWS. The main purpose of AWS KMS is to store and manage those encryption keys. Now I wrote a blog post about data encryption on AWS that goes hand in hand with this video. You can check that out in my personal blog, thecloudtutorials.com. Here is it. So if you like this content, make sure you subscribe so that you will be notified as soon as I publish a new video on every week. Now here's the outline for today's episode. So we will start by understanding what is KMS and why is it being used in the industry. We will also discuss the main concepts around KMS. Then I will show you a couple of demos on encrypting and decrypting using OpenSSL as well as AWS Encryption SDK. Finally, we'll conclude this video after discussing server-side encryption for AWS services like S3, EBS, and DynamoDB. I'm really excited about this episode. I hope you guys too. So let's get started. Now, I plan for 2 demos. In order to understand those demos, it's vital to learn how KMS works. So I dedicated this video to understand the theory part, and in the next video, we will do the demos directly. So if you're already familiar with KMS, skip this video and go to the next one. I will upload it quite soon. Okay, so why do we encrypt our data in the first place? Imagine your database server got hacked. Now that hacker has full access to your client's sensitive data. So if you stored your data in plain text, the hacker can do whatever he wants with the data, right? And usually hackers don't do good things with it. But if the data had been encrypted, the hacker would have a hard time decrypting that data, even if he hacked your database server. So encryption is vital, especially if you are dealing with sensitive data. And also there are a lot of regulations like GDPR that enforces you to follow security by design architectures. And of course, encryption is highly recommended for a security by design architectures. Now, when it comes to encryption of your data, you must consider encrypting your data both in transit as well as in data at rest. Now, imagine that you are delivering your website over HTTPS and you have associated a SSL certificate for your domain. So, the data that is transferred between your server and the customer's web browsers are encrypted. So, with the SSL certificate, you encrypted the data in transit. However, as soon as the data reached to the server or the load balancer, or it could be CloudFront, and the SSL is terminated, then you have to deal with the plain text data again. So if you store that data in database, that would be in plain text. Now to avoid that, you got to do encryption at rest. Now there are 2 main methods. The first one is client-side encryption, where you can encrypt your data at the client side and send all the way to the server or any backend services like S3, EBS, Redshift, etc. And the second method is server-side encryption. In server-side encryption, you let your backend services to encrypt the data and manage those keys on your behalf. So in client-side encryption, you encrypt the data and manage your own keys. And also you can use KMS as a key management infrastructure. If you don't want to use KMS, you can manage it by yourself as well. In server-side encryption, you let AWS to manage your keys for you. Most AWS services like S3, EBS, Redshift provide server-side encryption, and they also use KMS behind the scenes. So the point that I want to highlight in this slide is that KMS used in both server-side encryption as well as in client-side encryption. Now we already talked about KMS. So what is it? It is the main service that manages the encryption keys on AWS. Now these keys that AWS KMS manage are called customer master keys or CMK for short. Now I personally like if they refer it as just master keys without that customer part, because there are 2 types of CMKs, customer managed CMKs and AWS managed CMKs. So the name is a bit confusing, but we'll talk about that later. Now AWS KMS store these CMKs or customer master keys in hardware appliances called HSM or hardware security modules. Now these HSMs are tamper-free devices. So if anybody try to tamper with it, it's going to delete all the keys that it has stored. So it's quite secure and it is compliant with many security standards like FIPS 140-2. Now AWS makes sure those encryption keys never leaves this hardware appliance. So if it is never leaving the hardware appliance, so how are we going to interact with it? For that, we are going to use KMS API. Now KMS is integrated with most of the AWS services, like I already mentioned S3, EBS, Kinesis, etc. The main reason is that most AWS that deals with data, they support encryption. So in order to support encryption, they have to talk with or work with KMS. And also, the KMS is integrated with CloudTrail. This allows you to monitor the usage of your keys. For instance, you can see who used my key, for what operation did they perform with the key, etc. And this is very important to comply with different regulations. Now we already discussed about CMKs or customer master keys, which is the only type of encryption keys that KMS manage. And those keys are stored in HSMs and they never leave the region, or in fact they never leave the hardware security module itself. Now here's the thing about CMKs. They can only encrypt maximum of 4 kilobytes of data. So what if you want to encrypt hundreds of megabytes of data? Then you have to use something called data keys. So data keys is the second type of key I introduced to you in this video. Now these data keys are generated from a particular CMK or customer master key. So they have this relationship. And you can generate many data keys out of one customer master key. Now look at the diagram at the left side. Now here is the CMK that is inside KMS. And I can create one of these CMKs using AWS KMS console, AWS SDKs or CLI. Now I have a large amount of data to be encrypted and I can't simply use this CMK. So I need a data key. So I go ahead and ask my CMK to generate a data key for me. So I can use that data key to encrypt my large amount of data. So I make a call to the KMS API and then KMS will send me not just one but two versions of the data key. Now one of that data key version is encrypted by the KMS. So we call it encrypted data key. And the other one is the decrypt version of it or the plain text version of it. So what I do then is I use this plain text data key to encrypt my large amount of data, and as soon as I am done with the encryption, I will delete this plain text data key. Because if I keep this plain text data key that I use to encrypt my large amount of data together with that encrypted data, then if anybody found this plain text data key, they can easily decrypt it. I don't want that happening, so I remove it immediately. Now instead, I will store the encrypted version of that data key together with that encrypted data, or we call it ciphertext. Now this diagram shows how I used my plain text data key to encrypt large amount of data. Now this plain text data is, let's assume this is the large amount of data that I have to encrypt. So once I encrypt it with my plain text data key, it outputs the ciphertext, or this is the encrypted data. And no one can understand the content of this ciphertext. It is like totally scrambled. So after encrypting this, I will remove this plain text key and I will store the encrypted version of the data key together with this ciphertext. By the way, you can use OpenSSL or AWS Encryption SDK to do this encryption process outside AWS. I'll show that in the demos in the next video. So now the question is, how do I decrypt this ciphertext? Because no one can understand this unless otherwise it is decrypted. And we have removed the plain text data key that is used to encrypt this as well. So if I want to decrypt it again, I again need the same plain text data key. But instead what I have is the encrypted version of this plain text data key. So what I will do is, I will take that encrypted version of that data key and call KMS and ask it to decrypt and send me the plain text version of it. Now don't forget, when we asked for the data key in the first place from the CMK, it sent me both the plain text version and the encrypted version of it. Now this encrypted version is encrypted by the CMK. So since that CMK is inside the KMS, Now KMS knows how to decrypt it using the same CMK. So KMS will send me the plain text data key without an issue. So I can use this plain text data key to decrypt my ciphertext. Now this is how KMS works, and it is vital to understand this process. So today's demo is about how to use AWS KMS and OpenSSL in order to do encryption and decryption. And in the following video, we will discuss more about encryption and decryption using AWS Encryption SDK, which is one of the easiest way to do the encryption. Alright, so let's go straight to the video and I'll see you in the other side. So as usual, I have written all the steps for this particular demo in my personal blog. So there's this blog post called Data Encryption on AWS Part 2. So here I discuss all the steps that you have to follow. So it starts with creating a CMK, generating data keys for the CMK, and all the coding examples as well. In fact, we are going to follow this blog post for this particular demo as well. So let's get started. So imagine now you have to encrypt some data. It could be sensitive data. So in this case, we'll say you have some passwords that you need to protect and you have to block all the unauthorized access to that. So you choose to encrypt those data using AWS KMS as the key management infrastructure for keeping your keys and managing those encryption keys. So you don't have to worry about who else is able to access the data legitimately, because AWS provides an easy way of managing those authorization. And we discussed all that in the previous video. So the very first step is for you to create a CMK or customer master key. So I will go to my AWS account. Then I will pick AWS KMS. So I can search for KMS if I type in here. Here it is. And KMS is AWS Key Management Service. So in order to encrypt our data, very first thing we have to do is to create a master key, and we call it customer master key. You can do so by clicking create key here and make sure these keys belongs to a particular region. So you have to pick the region here. So right now I'm choosing Frankfurt and I'm choosing symmetric key. So in this particular region, asymmetric key is not yet available. But if I pick another region like North Virginia, so now I can choose between asymmetric and symmetric. Now asymmetric is public and private key pairs. Now it is recommended in AWS to use symmetric key encryption. Now if you click this particular link, help me choose. Now it says that symmetric key encryption is fast and efficient. And you can read more about this in this particular page. So however, we are going to use symmetric key. And I will click next. So now I can create an alias for my key. So this is used to easily refer my CMK or the customer master key. For this, I will call it demo. And then I will click next. Now here I can pick who are the administrators of this key. And in the next screen, we can designate who are the users of this key. So as the root user, I always has full access to this key. Or else you can pick your different IAM users in order to administrate these keys. I will choose my IAM user, Manoj. I will click next. And this is the page where it asks who can use this particular key. For that also I will pick Manoj here. Click next and I can verify the key policy. As you can see, the key administration is allowed for Manoj, and as well as the key usage is also allowed for Manoj. Then I will click finish to create my key. Now this is the key I just created. You can see it's a symmetric key. So this is the key that I use to encrypt and decrypt my data. Now I will keep my blog to the right side of the screen so I can follow it easily. And on the left side, I have created a text file called passwords.txt. Now this is the file that I want to encrypt, because imagine that this file contains my database password and server passwords, Facebook password, and all those sensitive information. So I don't want anybody to access that except the people that I trust. Or maybe the Facebook, I will remove it entirely because I don't want anybody to access my Facebook password. So imagine now I want to encrypt this. So the very first thing is to create the CMK, which we have already done. So now that we can use that CMK. So in the previous video, we discussed the CMK can only encrypt up to 4 kilobytes of data. So this file probably under 4 kilobytes, but let's assume there's a larger file that you want to encrypt. So in that case, I have to generate data keys out of my CMK. So in order to generate data keys, I will use AWS CLI. So this is the command that I'm going to use to generate data keys out of that CMK I just created. So I will just copy this command and I will take an integrated terminal. By the way, you need to have AWS CLI already installed. I will put a link in the description how to install AWS CLI for any operating system. So once you have installed it and configure it, you can just check the version, AWS dash dash version. There we go. So I have 1.6.2 CLI version. So now I will paste that CLI command. So I'm calling the AWS KMS service, and there's this particular command called generate data key, which is the one we want, and we have to pass the alias of our CMK. Now the alias we called it demo, so I will name it alias / demo. And the key specification that we are going to use is AES underscore 256, so advanced encryption standards, which is supported by our symmetric key. And of course, we have to define what is the region. And I think we finally created our CMK in US East 1 or North Virginia region. Then I will hit enter. So this should return me two versions of data keys. There we go. So I have the plain text data key and I have the ciphertext or the encrypted version of that same data key. So I'm going to store these into two different key files. So I'd like to copy it in the console itself, but rather I will create another set of key pairs and I will put that into a file called keys.txt. So if I open this left sidebar, I should see the keys.txt file, and this is my plain text key and the ciphertext. So I will copy this data key plain text version and I'm going to store it in a file called data key. So you can obviously name it anything here. So what I will do is I will do echo, paste the string, and I will do one other thing as well. Now these keys, the plain text key and the ciphertext or the encrypted version of the data key, are base 64 encoded. But if you want to encrypt your data, first you need to decrypt it. So I will pipe this plain text key through base 64 converter or base 64 decoder rather, and the output I will put it to a file called data key. Hit enter. There we have it. So I have this base 64 decoded version of our data key. Now in the blog you can find the command here. And similarly, I will decode my encrypted version of data key as well. So let me copy this key. Again, echo. Then pipe it to base 64 tool -- decode, and then the result will be stored in a file called encrypted data key. Okay, so encrypted data key is also stored. So this is the encrypted data key, the decoded version of that. So that is our very first step. So now we have the data key and the encrypted data key in order to encrypt our data. So this is our sensitive data. So now what I'm going to do is I will use my data key to encrypt this data, and then I will remove this data key altogether because I don't want to keep it with my encrypted data, because if anybody could find this encrypted data and if the data key is also stored with it, they can easily decrypt it. So I don't want that happening. So I will remove that afterwards. And then I will store this encrypted data key version together with my data wherever the location I store this file. It could be a EC2 instance, it could be EBS or anywhere. So before that, let's encrypt this data with our data key. So if you go to step number 3 in the blog, encrypting data, you should find the OpenSSL command. By the way, OpenSSL is a cryptographic library, and you can simply search for OpenSSL. In Mac and Linux, I think it is already available. So if you go to OpenSSL, and you can download it for Windows and other operating system as well. Okay, so let's get back to our blog post. And this is the command that we have to use in order to encrypt our data. So if you see, it is OpenSSL, ENC is encryption, and we have to provide the input file, which is password.txt, this file, and the output of that file, the encrypted version, will be stored in a file called password-encrypted.txt. You can name it anything you want. And then the encryption that we use is of AES 256 standard. And then we have to provide the key. Now this -k flag is where we have to specify where the data key is location. So you have to say file b : / the name of the data key. So in my case, it is just the data key name again. So then I will hit enter. If I open the file explorer, I should see the password encryption version. Now nobody can see these passwords. So at this point, what I'm going to do is I'm going to remove my data key. So let me delete it. I will remove the password, the normal text password as well, which I don't need anymore. Now I will store my encrypted data key as well as my encrypted data here. Now at a later point of time, I would again need to see my passwords. So how am I going to decrypt it? Because right now I cannot decrypt it because I don't have the data key that was used to encrypt this password. I only have the encrypted version of that data key. But remember from our previous video, AWS KMS keep a reference between my encrypted data key and the plain text key. So I can call my KMS and get the plain text version of it, which is exactly what we are going to do next. So let me clear the screen. And step number 4. So this is about decrypting data with encrypted data key. So first of all, I have to call AWS KMS again. So let me copy this command and I'll paste it here. So I will use AWS KMS. The method that we are using is decrypt. Then we have to specify our encrypted data key, which is ciphertext-blob, the location of that with file : / and its name is encrypted data key, the location and its name, the region USD is 1. If I hit enter, this should return my plain text key. There we go. So this is the data key that I previously used to encrypt our passwords. So what I will do is I will again copy this data key into a file. Before that, I will pipe it through base64 decoder. I will just call it data key itself. I will hit enter. Now I should find the data key. So now that I have the data key, I can easily encrypt my encrypted passwords and retrieve the original passwords. So let's do that. So that would be the final step. So I will again use OpenSSL cryptographic library for this. Let me clear the screen and paste this command. So it is OpenSSL ENC. I have to input the encrypted file location. So it is password-encrypted.txt and the file that I want to output it to. You can give any file name here. I'll just say password decrypted. Then I have to use -d flag for decrypt. The encryption standard is AES 256 and we have to provide our plain text key, which we just got from KMS. So that is data key and I will hit enter. Okay, it looks like it's successful. So let's view the file, which is password decrypted.txt. There we go. I have my original data back. So this is what I want to cover in this particular video. So this particular video is about how to use AWS KMS with OpenSSL. So in the next video, I will show you a demo how to use AWS Encryption SDK, which is very easier even than this. So in the previous video, we showed you how to do encryption and decryption using CLI. So in that video, I told you we can use Encryption SDK to do this quite easily. I want to give you a quick context around AWS Encryption SDK. The main reason is AWS provide 3 types of encryption SDKs. So one of that is DynamoDB encryption client and S3 encryption client and AWS Encryption SDK. So the recommendation from AWS is as follows. If you are directly working with DynamoDB, go with DynamoDB encryption client. Because you and me both know when we are storing data in DynamoDB, those data requires key attributes. So this DynamoDB encryption clients do not encrypt those key attribute, but the rest of the payload. Because of that, you don't have to do further processing when you are storing that data in DynamoDB. Uh, but if you use AWS encryption library to encrypt those data, it doesn't care about those key attributes, going to encrypt everything so that before you save it in DynamoDB, you may have to do some pre-processing also. So similarly, if you are interacting with S3, it's best to use S3 encryption client. If you just want to encrypt data in general in the client side, it could be in your browser, it could be EC2 instance or Lambda or any microservices within your distributed system. So you can simply use AWS encryption client. So let's see how to do that. I'll see you in the other side. All right, guys. So as usual, we have another blog post written with all the information that is relevant to this particular demo. So you can go to cloudtutorials.com and AWS Encryption SDK blog post. And there, like I explain, different steps that we follow during the demo as well. So I'll put the link in the description for your reference. Okay, so how do we use AWS Encryption SDK? Now, AWS Encryption SDK is available for multiple languages. So currently it supports JavaScript. Now this is both browser and Node.js, and C, Java, Python, etc. Now for this demo, I'm going to use Node.js. So we'll assume that we have a microservice in our distributed system where we need to encrypt all the data that is generated by that microservice before transferring out to the other microservices. Now let's use Node.js for this microservice, but it's quite okay to use a different language, like let's say Java or Python in other microservices where it needs to decrypt this data. So one of the points to remember is that you can encrypt using any SDK. Let's say in this case I use Node.js to encrypt my data, but I can use a different language, AWS Encryption SDK, like let's say Java SDK, to decrypt that same data. So another instance could be you can encrypt data in the browser using AWS Encryption SDK for the JavaScript, and in the backend, let's say it's a Java backend, you can use the encryption SDK for Java to decrypt that. Now in the introduction, I told you there are two other encryption libraries that is provided by AWS, like DynamoDB encryption client and S3 encryption client. However, these libraries are not interoperable. For example, if you encrypt using S3 encryption client, then you cannot decrypt using AWS Encryption SDK for JavaScript or any other programming language. I hope it's clear. So let's go ahead and start using the encryption SDK for the Node.js. Now, very first step is to install the SDK. So you can easily do a npm install at AWS Crypto client-node. So once you have installed it, you can require these functions or methods from the Node.js SDK. So there's a method called KMS keyring node, encrypt and decrypt. Now encrypt and decrypt is self-explanatory. Encrypt is used to encrypt the data, decrypt is used to decrypt that data. But what is this keyring thing? In previous videos, I talked about the master keys and data keys. Now what's the difference between these two? So small recap, we store master keys in AWS KMS, and KMS manages those master keys. But in order to encrypt large amount of data, we cannot use master key because master keys are only allowing up to 4 kilobytes of data encryption. So in that case, we have to use data keys. Now data keys are generated from a master key, but we have to manage this whole process. So in the last video, I showed you how to request the master key and how to request data keys, and then use those data keys to encrypt and then later decrypt those information. But what keyring does is it will manage this whole process. So only thing that we have to do is providing a master key to the keyring, and then it will manage the creation and the management of these data keys. Now let's go to our code editor. Now, as you can see in the very first line, I am requiring encrypt, decrypt functions as well as this keyring. Now I have to provide a master key to this keyring. So in order to do that, I created a KMS master key. Let me quickly show you that. So I am in my AWS console. If I go to KMS or key management service, now at the moment I have these two keys. So I go to this YouTube master key and I copy this ARN, and here I will paste the ARN as my generator key ID. So I need to pass in this generator key ID into my keyring. Now you can add additional master keys into this keyring as well. So why do we even need these additional master keys? Now we discuss the data keys are encrypted by master key. So all the data keys that is generated by this particular master keys are encrypted using this master key. But AWS allows us to encrypt it using another master key. So it's like two levels of encryption. And also you can encrypt it again and again. So that's why we can define a set of key IDs in this particular key IDs array. So what I have done in this particular demo is I created another key called demo, and let me show you that ARN. So this is that ARN. So I copied this ARN and added as a key ID. I can add many other key IDs here as well. So what I'm doing is when I'm creating my keyring, I'm passing my generator key as well as all the other key IDs that I need to use for additional encryption. Alright, so now that we have the key ring, we can start encrypting and decrypting our data. Now if I scroll a little bit down, you can find there's a method called init. Now I have defined a variable called plain text. Now let's assume this is the data that I need to encrypt. So in this case, let's say these are the passwords for a sensitive data. It could be the connection string to my database. So let's say this is my data I need to encrypt. And then I can define an encryption context. Now, when I'm encrypting with AWS Encryption SDK, I can pass an additional context to the data that I am encrypting. So what happens is the encryption function will both use this plain text as well as this context to encrypt the data. So why would I do it? Because this is a best practice. Now let's say later down the road you want to decrypt this data. So once you have decrypted this data, if you want to verify if this data has been tampered somewhere in the middle of the communication, I can use this context to do so. Because now these are distributed systems, right? So at any microservice or any third-party service can somehow find these encryption keys and then decrypt the data and change it and send it back to another microservice. So if we want to make sure that it's not tampered, then we can use this context. I'll show you how to do that in a bit. Okay, so now we have the plain text and the context. Then I'm passing both this plain text and the context to encrypt function. Now let me go into this particular function. There we go. So the encrypt function, it takes in the keyring that we defined earlier and then the plain text, and it also accepts the encryption context that we passed. So as the result, we get the encrypted data. So this function returns that encrypted data. Now let's say I want to decrypt it. So how would I do that? So I just have to pass this encrypted data and the context. So I pass this context, that is the original context, into my decryption function. Let me go into this function again. There we go. So the original context is passed along with the encrypted data. Then I will just use the decrypt function passing in the keyring and the encrypted data. So the result would be the plain text and the message header. Now this message header contains the encryption context that was available inside this encrypted data. So what I can do next is I can access this encryption context. There we go. And then I will check that against with my original context. So this is how that can be done. So I will go over all the attributes of the context. So that means these attributes: stage, purpose, origin. Now I can add, let's say, account ID and all that useful information. Now this will be useful if you are dealing with a multi-tenant application. I will remove that for this demo. So I go over each of these attributes values and compare it with the attribute value that is associated with the message header. So if all those attributes are matching, we can conclude the data has not been tampered. But if one of those attributes are not matching, then the message has been changed somewhere in the middle. So that's basically how we do encryption and decryption. So let's run this and check. So I'll take a terminal. I will just execute node index.js. There we go. This is my original data. And it returns me the encrypted data after encryption. And then here I go ahead and decrypt that data. Now I'm console logging the message header, and you can see in the message header it comprises of the context attributes, origin, purpose, and the stage, these three. Then I compare it with my original context. You see I got a match. So I'm happy that nobody else has decrypted and then changed my message somewhere in the middle. And finally, it prints out the decrypted message, which is exactly the same original message. My passwords for sensitive data and my passwords for sensitive data. Now I hope this is clear. I will include a GitHub URL for this particular code. Thanks for watching guys. I'll see you in another episode.